Okay, so in this video I'm going to show you guys how to model your geometry that you'll be cutting out of the on the CNC Hotwire. So the first step is to go to the D2L page, go to Workshop Files, CNC Hotwire. And you're going to want to download this 3DM file, Hotwire, CNC Hotwire template. Just right click on it and download it. Then go to Rhino. And open that file up. Now, what you'll find in this file is a 3D representation of the actual Hotwire machine. So like the red is the base of the machine. This little red object is the platform that the blocks sit on when we Hotwire. The blue represents the bounding space. So this is the maximum workable area for a piece of material to cut. And the green represents the surface that the two ends of the Hotwire are moving from, or moving between. So what I'm going to do is show you how to model using this as a template, and then set up your 2D files to bring it into the CAM software and make a file that's ready for running on the CNC Hotwire. So the first thing we want to do is, as you can see, there's a left side and a right side in this 3D model. So I'm going to go ahead and go to the left viewport. The first thing that I want to do is I want to model my stock. So if I go and set that to my current layer, the stock, I actually want to be in top view, I'm sorry. So go back to top view. What I want to do is model a box. So the beginning step is to just model the kind of volume of the material that you're going to cut out from. So I'll use the command box. I'm going to choose the option for center, and then I'm going to snap to this point that's in the middle of my cutting bed. And I'll just enter the dimensions. So our block is 8 inches by 8 inches by 5 inches tall, or 5 inches deep. Okay, so that's our little foam block, and that's the volume that we're going to cut our geometry out of. The next step now would be to go to the left viewport. I'm going to change my layer to geometry, and then I'm going to model in the left viewport just a polyline, or just a line actually. So I'll type the command line. It's important now to make sure not to snap to anything, because in our 3D model this left side of the machine is actually on the drawing plane in our left viewport. So I'm just going to draw out in space for right now, and then I'll align it to my box later. So I'll click somewhere. I want to make this line 4 inches long. So I'll type 4 and hit enter, hold shift to draw it straight. And that line will represent the bottom, or one of the edges of our polygon. Now what I want to do is rotate this edge. So I'll use the command rotate. Make sure the copy option is set to yes. I'll snap to the front of the line. And then I'm going to rotate it to 120 degrees. So I'll just type in 120, press enter. I'll press enter again. Okay, and then I can just go ahead and copy these two lines. So I'll copy that diagonal, and I'll copy my horizontal. Okay, and so we've drawn a really simple diamond-shaped polygon. Now I'm going to select all these lines and join them, first of all. And then now we have a closed outline. So when you're modeling for the Hotwire, you always need to use a closed outline. And I can actually go ahead and align this to my stock box now. So I'm going to go ahead and move. Make sure that the O-snap center is turned on. I'm going to snap to the center of this object. And I also want to go down here and hit this button, project. So what I actually want is to move it to that middle point that's floating inside of my base, that center point. But because I turned on the option project, that means I'm only moving it on this drawing plane still. So now I'll go ahead and move it up, and I'll snap to the top edge of my polygon, and then I want to snap to the top edge of my stock in a straight, in a straight movement. Because we want the cutting profile to actually be aligned to the top of the stock box. Okay, and now I'm going to demonstrate how you would actually model and predict what the kind of form would be if you were to cut this on the Hotwire. So the next thing I want to do is actually use the command wire cut. So it'll ask me for a line first. I'm going to choose this line. It'll ask me for the objects that I want to cut. I'll choose my stock box, and then I can just draw this line out somewhere past where the box is. So I'll click out there, and you'll see that it has automatically separated our box into two separate poly surfaces. And so that's the same type of operation that would happen when we actually go and put this on the machine and run this profile line, right? So we have essentially a straight wire or a straight line moving between one side of the machine and the other, and then following this path. So it would cut that profile out of our stock box. Then the next step would be to take both of these objects that we've just split, type in rotate. We're going to turn off the option to copy, and I'm going to switch into a wireframe so I can snap to my center point, and then I'll just rotate it 90 degrees. And once again, I'll just repeat the command wire cut. So I had that polygon selected already. It wants me to select the objects that I want to cut. So I'll select those two poly surfaces. Again, I can just drag it out. I also just want to point out this option keep all. You want to make sure that's set to yes. Otherwise, it'll actually just remove what you've trimmed with your wire cut command. So I'm going to drag it way out past my block. And boom, there we go. So we've cut our geometry into a bunch of different parts. Now I'm going to go ahead and pull this away so you can get an idea of what we've done here. So within that block is basically the three-dimensional intersection of this projection. So if I pull that guy out, you can see we have this kind of polyhedron, three-dimensional solid geometry. But because we cut it on the Hotwire, all the Hotwire really removes is a thin line where it actually melts the foam in order to cut through it. And therefore, we're also left with all the other parts of our geometry. And these parts that remain can be reassembled because we are also then left with a negative, the negative of that same volume. And we can use that negative, we can reassemble those parts to make a formwork to cast concrete into. So that's the basic operation. Just for demonstration, I also want to point out that there's a lot of different types of geometry that you can do on the Hotwire. One of the other ones you can do is if we were to go into left, we already have one profile. We could draw a second profile. Let's say just a circle or something like that. Now you can see we've drawn both these objects on the same plane, but because our Hotwire machine has like two axes on either side of the machine, it can go up and down, left and right, we can actually cut different profiles on either side of the machine and create like a volume or a shape that was interpolated between those two. So first I need to move my second profile to the right side, where it says right side on the other end of the machine. So I go back into left view, type in move, hit this option for vertical, snap to the circle, and then I can move it out to where that drawing plane is. if I go back. So now I have these two different shapes. If I select both these shapes and type loft, I can get a kind of rough estimation if I loft these two shapes of the movements of the Hotwire, or the kind of shapes that the Hotwire would make as it interpolates between these two different profile lines. So I'll click OK. And then I could also cap this. And in this case, I would go ahead and just do a Boolean split. So Boolean split. Sorry, let me start that again. Select surfaces to split, which is our stock box. Press enter. Cutting surfaces, which is our lofted object. And you can see that we'd be left with this kind of shape from within our volume. And you could even, you could do multiple intersections of this, or you could rotate it again. So just to point out, this is actually a 4-axis machine, which means it has 2 axes on either side. It can cut really complex forms using this method of interpolating between profiles. Now, back to our original geometry. What we want to do next, so I'm going to go ahead and delete this stuff. I'll move my box back, or I'll just make a new box. 8 by 8 by 5. Okay. So if I go back over into left view, I'll reset my viewport. I'll just type left in the command line. Okay. Now what we need in order to actually cut the shape on our Hotwire is we need a reference point. And for right now, what we're going to do is we're actually going to use the stock box as that reference point. So what I want to do is draw a rectangle that represents the outline of this stock box on the drawing plane. So I'm going to turn the project option back on, just draw an outline of my box. Okay, and then if I were to orbit, you can see there's my geometry, there's my box. And then what I want to do is go over here to where it says starting point, make sure that I'm in top view, and I'm going to use the command orient 3-point. I can also turn off project. And I'm going to go ahead and snap to the top right corner of that profile, of the stock box profile. And then I can choose any sequence of the other edges to snap to. So I've chosen 3 points as reference points. Now it's going to ask me for target points. So first, I want to actually snap it to the 0, 0 of my file. So I'll type 0, 0, press enter. And now I can just use shift to snap to ortho and align it to the top plane, or the XY plane of my file. I think there was already a line here, so I'll just delete that. Okay. Now what this means, starting point, basically when you send a file from a software to a digital fabrication machine, it needs to know where you want it to actually do its work. So what that means is, when we go onto the Hotwire and we slap a block of foam down in the middle of the bed, we need to actually align the Hotwire to that piece of foam in order for it to know where we want it to cut, right? Unless we use the bounds of the machine, which doesn't really work well on the Hotwire, we need to actually zero our Hotwire to our block, to the top right-hand corner of our block. So when we move this profile line so that the top right is at 0, 0, that means that when we export this profile line and bring it into our CAM software, it should automatically know where we want to zero and then where we need to cut out of our block. So we'll get our geometry cut out of our block in the right location, and we won't waste our material. Okay, so I think that concludes this material. or I'm sorry, this tutorial, and there will be one more describing how to use the CAM software, and then one more showing you guys how to digitally model this geometry and use it in your representations. Okay, sign off.